Newton's laws of motion. In this video, we will look at the Newton's laws of motion. We'll state them, then we'll see some work examples. So let's begin with the first law of motion. Newton's first law of motion states that every object continues either at rest or in constant motion in a straight line unless it is forced to change that state by external forces acting on it. Then the reluctance to stop once it is in motion is referred to as inertia, or once it is at rest, the reluctance to set in motion is referred to as inertia. Newton's second law states that the time rate of change of linear momentum is directly proportional to the force causing the change, and the change takes place in the direction of the force. Then the third law says that to every action there is an opposite and equal reaction. To every action there is an opposite and equal reaction. Now let us see how we can solve questions on Newton's laws of motion. We have the first question here from WASSCE, May, June 2012. The tendency for a stationary body to continue to remain at rest when a force is applied to it is known as. So the answers are friction, impulse, inertia, momentum. So like we saw, the correct answer is option C. Now let's look at the next question. State Newton's second law of motion. State Newton's second law of motion. That is from WASSCE, May, June 2000. So we saw this one too, and it says that the time rate of change of linear momentum is directly proportional to the force causing the change, and the change takes place in the direction of the force. So as simple as that. Now let's look at the next question. WASSCE, May, June 2000 again. Show that F is equal to ma, where F is the magnitude of the force acting on a body of mass m to give it an acceleration of magnitude a. So this is the magnitude of acceleration, and this is the mass of the body. Okay, so let's see how we can do this. Recall that this has to do with the second law, the Newton's second law, and you know what that law says, that the time rate of change of momentum, so the time rate of change of momentum is directly proportional to the force in the direction of the force. So if F is the force, and then it is directly proportional to the change in momentum. So that will be the change in momentum is given by the mass times the final velocity minus the mass times the initial velocity u. Okay, so that is a change in momentum with respect to time. So over time. Now we can introduce a constant, but before then let us factor the mass out of this to get F to be equal to F to be directly proportional to m into v minus u all over t. Now we can introduce a constant of proportionality k. The constant of proportionality k, then that will bring an equal sign over here. Then we have our mass, our k times the mass. Then we have, now recall that change in this is final velocity minus initial over time. So change in velocity over time will give you acceleration. So this will give you acceleration. So the magnitude of that acceleration is a. Now we also know that force is measured in newtons, and we know that from system of units, the newton is the force needed to give a mass of 1 kg and acceleration of 1 meters per second squared. So that will mean that we must have our k here to be equal to 1. So this will mean that we will now have our force F to be equal to 1 times ma. So that will give us F to be equal to ma. As required. So that's it. That's what they wanted us to show, and we have done that. Now let's look at the next question. A resultant force of magnitude 15 newtons acts on a body of mass 250 grams. Calculate the magnitude of the acceleration. So from the question, we have the force to be equal to 15 newtons. Then we also have the mass of the body to be equal to 250 grams, but we need to convert this 250 grams into kilograms. So we obtain that by dividing the 250 by 1000. So we get 250 over 1000, and 250 over 1000, that will give us 0.25 kilograms. So 0.25 kilograms. So we now substitute into the formula, because we are supposed to calculate the magnitude of the acceleration. So from the formula F equal ma, we can make the acceleration the subject to get a to be equal to F over M. So we just substitute the force and the mass to get 15 over 0.25. But this 0.25 is the same as 1 over 4. So let's rewrite to simplify. We get acceleration is equal to 15 divided by 1 over 4. So let's reciprocate and multiply by 4 to get the acceleration is equal to 15 times 4, and this is the same as 60 meters per second squared. So the answer is option D. The answer is option D. The engine of a vehicle moves it forward with a force of 9,600 newtons against a resistive force of 2,200 newtons. If the mass of the vehicle is 3,400 kg, calculate the acceleration produced. So this is similar to the previous one. So from the previous one, we saw that the acceleration is equal to force over the of the mass from the question. But note that the force is a net force. So the net force will be equal to 9,600 newtons. 9,600 newtons minus 2,200 newtons. And when we do the subtraction, what will this give us? Let me check this on my calculator. So doing the subtraction, we get 7,400 newtons. So that is the net force, 7,400 newtons. So we also given the mass from the question to be 3,400 kg. 3,400 kg. So we can now use the relation A is equal to F over M to calculate for the magnitude of the acceleration produced, and that will be equal to F, which is 7,400 divided by 3,400. 3,400. We need to make use of our calculators again. So when I divide, I'm getting something like so the division is giving me 2. It's giving me 2.1765. So we correct this to 2 decimal places to obtain 2.18 meters per second squared. 2.18 meters per second squared.